Dear students, we are going to discuss about the corollaries in detail one by one. So before getting into corollaries in detail, we are going to revisit the axioms which we already discussed and the basics of the corollaries. Axiom one is known as the independent axiom. We maintain the independence of the component. Axiom two is the information axiom. Minimize the information content of the design is the purpose of the information axiom. So axiom 1 states that during the design process, as we go from the requirement and use cases to a system concept, each component must satisfy the requirement without affecting the other requirement. Each component must satisfy the requirement without affecting the other requirement. Axiom 2 is concerned with the simplicity. The best theory explains the known facts, the minimum amount of complexity, and the maximum simplicity and straightforwardness. So these two are the axioms. So as per the Occam razor rule of simplicity in object-oriented terms, the best design usually involve least complex code, but not necessarily fewest number of classes or methods. Minimizing the complexity should be the goal because that produces most easily maintained and enhanced application. In an object-oriented system, the best way to minimize the complexity is to use inheritance. The best way to minimize the complexity is to use inheritance. The system built in classes and to add it as little as possible to where already is there. So they inherit from the super classes. Every class inherit from the super classes and add little more whenever needed. Corollaries. Corollary is a proposition that follows from an axioms or another proposition that has been proven. So here we are having six corollaries. The corollary 1, 2, and 3. Corollary 1, 2, and 3 are depends on the axiom 1 and 2. Corollary 4 is based on axiom 1. Corollary 5 and 6 are based on the axiom 2. We'll see the six corollaries one by one. Corollary 1, uncoupled design with the less information content. That means highly cohesive objects improve the coupling because only minimum amount of information is passed between the objects. Corollary 2, single purpose. Each class must have a single and clearly defined purpose. Corollary 3, large number of simple classes. Keeping the classes simple allows reusability. Corollary number 4, strong mapping. There must be a strong association between the analysis object and as well as the design object. Corollary 5, standardization. Promote standardization by designing the interchangeable component and reusing the existing class or the component. Promote standardization by designing the interchangeable component and reusing the class or components. You have to, when you are designing a component, you have to think that reusability in your mind. Design with inheritance. Common behavior method must be moved to superclass. So common behavior must be moved to superclasses. Specific behavior should be in the subclasses. The superclass subclass structure must make a logical sense. So these are the things we already discussed. We'll go to the corollary one by one. So corollary one means uncoupled design with the less information content. So the goal of the corollary is maximize the object cohesiveness among the object and the software components in order to improve the coupling. Cohesive means the interconnection within the object is known as a cohesiveness. Self-sufficient is known as a cohesiveness. Okay, and coupling means the interaction between the objects is known as a coupling. When you improve the cohesiveness, by improve the cohesiveness, we can improve the coupling. That means we will minimize the coupling. Only a minimal amount of essential information is passed between the object. Only a minimal amount of essential information must be passed between the object. So coupling. Coupling is a measure of a strength of association among the object. Coupling is a measure of a strength of the association among the object. For example, a change to one component of a system should have a minimal impact on other components. Changes to one component of a system should have a minimal impact on other components. Strong coupling among the object complicate the system. If the coupling is strong, it complicates the system. The degree of a coupling is a function of how complicated the connection is. So how the degree of coupling is a function of how complicated the connection is. Where the connection refers to an object itself or something inside it. When the connection refers to an object itself or something inside it, you have to check that it refers the object itself or something inside it. Next, what is being sent or received? What is being sent or received from an object? Coupling increases with the increasing complexity of the interface. When the complexity of the interface increases, the coupling also get increases. Coupling decreases with the connection is to the complete interface rather than a component. Coupling decreases with the connection is to a component interface than a component. Okay, if you're directly not contacting a component, only you are contacting the component interface means you are requesting the service through the interface means the coupling will decrease. Coupling also is lower for data connection than control connection. Coupling also has a data connection. Data connection means when one object accesses the data of another object is known as a data connection. When one object control the as directly control another object is known as a control connection. So coupling lower with the data connection than the control connection. The two types of coupling. First one is interaction coupling. It involves the amount and complexity of messages transmitted between the object. It involves the amount and complexity of messages transmitted between the object. Keep the message as simple as possible. See, if the he is the object, it is having a highly complex connection. It's having a connection with the all the. So the coupling is high. This is the relationship is so complex. The object connected to many very complex messages are tightly coupled. The object connected to many very complex messages are tightly coupled, meaning any change in the one invariably leads to a ripple effect in the change in the others. Any change in the one invariably leads to ripple effect of the others. In addition to minimizing the complexity of the messages, reduce the number of messages sent or received between the object. In addition to minimize the complexity of the messages, reduce the number of messages sent or received between the object. So here we are having various type of coupling are shown here. Types of coupling among the objects or component are shown here. The first one is arranged from the very high coupling to very low coupling. So degree of coupling and name and a description. First, the degree of the coupling is very high. That coupling is name is content coupling. That means that the connection involves a direct reference to attribute or method of another object. One object can have a directly reference means directly access the attribute method of another object. This is known as a content coupling. So coupling is very high. Next, high common coupling. The connection involves two objects accessing the global database. Two objects accessing the global database for both read and write operations. That is known as a common coupling, but coupling is high. Next, medium coupling is known as a control coupling. The connection involves explicitly control of the process logic of one object by another object. The connection involves one object can directly access the process logic of the another object. That is known as a control coupling. So here the degree of coupling is medium. Next is a stamp coupling. The connection involves passing an argument data structure to another object, passing an aggregate data structure to another object, which uses only a portion of the component of the data structure. That means a stamp coupling. One object passes the data structure to another object, aggregate data structure, which is second object uses the portion of the data structure, portion of the components of the data structure. This is stamp coupling. Coupling is low. Next is data coupling. The connection involves simple data items or aggregate structure, all whose elements are used by receiving object. Okay, all just sending a data and receiving object is receive the data. This should be the goal of the architectural design. So data coupling is a very low. This is generally the goal of the architectural design. Next, we have to discuss about the inheritance coupling. It is form of a superclass and subclass relationship. Superclass is coupled, subclass is coupled to its superclass in terms of attributes and method. High inheritance coupling is desirable. Cohesion. Cohesion means cohesion is interacting with the single object or software component is known as a cohesion. It reflects the single purpose of an object. Highly cohesive components can lower the coupling because only minimal essential information is passed between the object. Okay, if the cohesion is high means it's an interconnection within the object is high means that means that they need a very minimal information from the outside, so coupling will be very low. High cohesive component can lower the coupling because only minimal of information is passed between the objects. Type of cohesion, method cohesion means the method should carry out only one function. Carry a multiple function is undesirable. Method cohesion means every method should carry out only one function. Class cohesion. A class, methods, and attribute must be highly cohesive. Class, methods, and attribute must be highly cohesive, meaning to be used by the internal methods and derived classes. Class, methods, attributes should be used by the internal methods and as well as derived classes. That is known as a class cohesion. Method cohesion and class cohesion. Method cohesion, the method should contain should carry only one function. Class cohesion means attribute and methods of a particular class is used by the other method of the same class or the inherited classes. Third is inheritance cohesion. It is considered the following question: how the classes are interrelated. Does the specialization really portally specialization as just something arbitrary? Whether you are developing a special class is really needed there or it is arbitrarily selected. How the classes are interrelated, how the superclasses, subclasses are interrelated. So if the answer is proper, then the inheritance cohesion is justified. Inheritance coefficient is justified. So that is known as a inheritance coupling. So we discussed two type of coupling. One is interaction coupling, interaction between the objects. Second one is inheritance coupling. So this is come under the first one, actually called one uncoupled design with the less information content. So you have to improve the coefficient and decrease the coupling.